A data set lists weight in pounds of plastic discarded by households. The highest weight is 5.73 pounds. The mean of all the weights is 2.82 pounds. And the standard deviation of the weights is 1.122 pounds. For part A, it says, what is the difference between the weight of 5.73 pounds and the mean of the weight? So the difference can be calculated by subtracting the mean from the highest weight or subtracting the highest weight from the mean. In this problem, we're going to subtract the mean from the highest weight. In this case, we're going to first set up the difference and then subtract. So we know that we have the mean, or the highest weight, which is 5.73. And then we're going to subtract the mean of 2.282. Now keep in mind we got to make sure that we add a 0 to this decimal place, but using our calculator, if we take 5.73, subtract 2.282, then we get 3.448. So that represents 3.448 pounds. So therefore the answer for part A is 3.448. Now the next question says, how many standard deviations is that? Meaning the difference found in part A. So we want to compare the difference to the standard deviation. And notice that to determine the number of standard deviations in the difference, we divide to determine the number of groups that are the size of the standard deviation in the difference. So we're going to divide the difference by the standard deviation and then rounding it to 2 decimal places. So we found that the difference was 3.448 pounds. And then we're going to divide it by the standard deviation. And the standard deviation in our problem up here is 1.122 pounds. So 1.122 pounds. And then we're going to round that to 2 decimal places. So let's go ahead and do this. 3.448, divide that by 1.122, and then we get 3.07 if we round out to 2 decimal places. And so that's going to represent the standard deviation error. So we get the difference is 3.07 standard deviations. So it doesn't represent standard deviations, it's the difference. So it's 3.07. Now in part C it says convert the weight of 5.73 pounds to a z-score. Okay, so by doing that, a z-score or standard score or standardized value is the number of standard deviations, whether it's a sample standard deviation or population standard deviation, that a given value x is above or below the mean, whether it's a sample mean or population mean. The z-score is calculated by using one of the equations shown below. So we have to decide whether it's a sample or population. Well, since we're given the sample mean and the sample standard deviation, we would say that in this case, the data are for a sample of households, not all households. So we're going to use the following formula. So we just need to identify what we need to plug in. So we know that x represents our data value, and our data value is 5.73 pounds. Okay, we also know that the sample mean from our problem that's in the question is 2.282. And then we also know that the standard deviation is 1.122. So now we're going to plug it into our formula. So z is going to equal the value of x, which is 5.73. We're going to subtract 2.282. And then we're going to divide that by the standard deviation of 1.122. Okay, so when we do that, we should get the same value. We're going to get 5.73 minus 2.282. And then we're going to divide that by 1.122. And again, we're going to round that to 2 decimal places. So we get a z-score of 3.07. So we get a z-score of z equals 3.07. Now in part D, it says if we consider weights that convert to z-scores between -2 and 2 to be neither significantly low nor significantly high, is the weight of 5.73 pounds significant? So now what we need to do is we need to compare this. Okay, so again, a value is significantly low if the z-score is less than or equal to 2, and a value is significantly high if the z-score is greater than or equal to 2. Otherwise, the value is not significant. Okay, so if this was our mean, which is 0, we know that over here is -2, over here is +2. So we know that anything below -2, in this case, anything that's below here is significantly low. Anything above +2 is significantly high. And anything in between is not significant. Now we need to look at the z-score. Well, the z-score that we found here is 3.07. And that 3.07 is to the right of +2, which means that this is a significantly high value. So therefore, the highest weight in this case is significantly high.